I am on page 33. Once you know how to solve equations, these inequalities are going to be much less of a challenge. They're going to work exactly like equations with one exception. So let's set some of them up and see what we can do. Let's solve, let's say 3x plus 5 is less than or equal to 21. So this is an inequality using less than equal to, and we need to solve it for x. So using that same method that we learned our equations with, let's draw the t-chart, write down the symbol, and on this side we have the variable, the x, and on this side we're going to bring all of our constants. Okay, so the first thing I'm going to do is move the 5, and that's going to be a minus 5, and a minus 5, you do it to both sides. You need to cancel at every step of the way. So we have 3x is less than or equal to 21 minus 5 is 16. And then we need to get the 3 over to the constant side. So let's divide it by 3. So x is 16/3. Or sorry, x is less than or equal to 16/3. And if you wanted to put it in mixed number form, 3 into 16 is 5 times with 1 left and a 3. So x could be anything less than or equal to 5 1/3. It could be 5 1/3, and it could be anything below 5 1/3. I think I'm going to graph this one just so you can see. If you make a line, put some arrows on there. Let's make a space for 5 1/3 or 16/3. You could write it either way. So we could include that, and then we could include anything below that line or that dot. Anything less than that amount could be a solution. Okay, let's do another one. Let me try to get one right in here. Let's do 16 is greater than or equal to, let's do a simple one. Let's do 4x. So again, if you want to use the method I showed you, we would draw the t-chart through the sign. Here's variable. This is a 1-step. Here's constant. So we're going to divide both sides by 4. That's the only thing that needs to move. And we're going to have x over here. That's what we want. And over here we have a 4. So 4 is the biggest that x could get. And if you want to graph this one, you have to be really careful here because it's written backwards. We're going to put 4 over here. But that x has to be smaller than 4. You have to look at the way the arrow's pointing. So this one would be anything 4 or below. All right. Let me do one right up here. I'm trying to conserve space. So let's do, let me think before I make a mistake here. Let's just do one with a plain old less than. Let's do a 100 on this side. 6m plus 2 is less than 100. So draw the t-chart. We're going to minus 2 from both sides. Actually, I'm sorry, I'm jumping the gun. Here's the variable. Here's the constant. The 2's on the wrong team. So let's move that 2 over the line. You have to do the opposite. So you're left with 6 m's, the inequality, and a 98. Then we're going to divide the 6 to bring it over to the constant side. And so you're left with m. I'm going to do this as a decimal. 98 divided by 6 is 16.3 repeating, or 16 1/3. Okay, let me do one with distribution just so we see how that works. Let's do 5x plus 2 is less than, actually let's do a greater than. I've done them all less than. Let's say a negative 12, because sometimes you have negative numbers. So the first thing I'm going to do is get rid of parentheses. I don't want to start anything until the parentheses are out of there. So let's do our distribution. 5 times x is 5x, and 5 times 2 is 10. And then you copy. And then you will do your thing here. So we have variable, and constant. And we're going to move the 10. So we're left with 5x is greater than negative 22. Divide by 5. So you're left with x is greater than negative 22. Oh, we don't have negative, sorry. 22 divided by 5 is 4.4. Those signs are different, so this answer is a negative. X is greater than negative 4.4. Okay, here is the one, this is where this can be a little different. So think through this one with me. Let's do a very basic one and then a not so basic one. I'm going to say negative 10 b is less than or equal to negative 50. So we don't have parentheses. We can go ahead and set up the t-chart. We have the variable on this side and the constant on this side. So we need to move that negative 10. So I'm going to divide by negative 10, and this is where the rule is weird. If you multiply or divide by a negative, you have to reverse the sign. And I won't go into why that is the case. Just trust me on this. So as soon as I realize, whoa, I'm dividing by a negative, this sign has to flip around. So it becomes this direction. Then we just continue as always. You cancel so that you're left with the variable, the flipped sign. 10 into 50 is 5. The signs are the same, so it is a positive 5. B is greater than or equal to positive 5. All right, let's do one where we have a fraction. Let me come down here. Let's do negative 1/2 of A plus 3 equals 7. Not equals, I'm doing inequalities. Let's make it less than or equal to 7. No parentheses, so let's go ahead and draw in our t-chart. The constants are going to go on this team, and the variable is going to be over here on a team by himself. We're going to isolate that variable. So the first thing we do is subtract 3 and cancel. So I'm left with negative 1/2 A. 7 minus 3 is 4. And then I have to deal with that negative 1/2. And that negative is the fly in the ointment here. Because as soon as I multiply by the reciprocal, I have to flip the sign in the middle. So here's the negative. This sign has to reverse. So these are going to cancel. We're going to have an A, a flipped around sign, and then 4 times 2 is 8. The signs don't match, so it's negative over 1. And that would simplify down to negative 8. I really believe these are more difficult than you're going to see. But just in case, those are some examples of inequalities. This is the 24-karat gold rule on these. You have to remember this. If you're multiplying or dividing by a negative, you reverse the sign.